Hello. Welcome to Afternoon Tea Onwards. Our first presenter, we have Brenda Moon. She is a PhD candidate in science communication at the ANU, where she is using data mining on social media to understand public attitudes towards science and technology. She is a keen supporter of open source, open hardware and open science. To talk to us about exploring science on Twitter with Ipython Notebook and Python Pandas, please welcome Brenda Moon.
Hello, I'm Brenda Moon and I'm doing my PhD in science communication at ANU, looking at how people use the word science on Twitter. My initial data collection was done using Java, but after trying a few different options for data analysis, I settled on Ipython Notebook and Python Pandas as my main tools. Today I'm going to give you a quick overview of how I've set up my research environment and then show how Ipython Notebook and Pandas help my research. I'm fairly new to Python, so I'd really appreciate any feedback about ways I could be doing things better. For research, being able to go back to something you've done a year ago, run it, and get the same result is really, really important. But the tools I'm using are improving very quickly, and I'd like to be able to take advantage of these improvements. I use Python virtual environments to help me achieve these goals. VirtualEnv lets you have a virtual environment on Python, and probably a lot of you have already heard of it, but I've always been surprised at how many people are not using them when they're so easy to use. VirtualEnv Wrapper makes VirtualEnv easier to use, and using VirtualEnv Wrapper has made trying out different Python modules much easier. And it lets me take advantage of the rapid development of the tools that I'm using without worrying about my code stopping working. I make a note of which virtual environment I'm using at the top of each Ipython notebook so that when I go back later on, I can know if it's stopped working in my new environment that I'm now using, I can know which one to go back to run it again, and then perhaps bring it up to date, or if I'm just checking something, just run it in the old environment. And part of doing that is that copy virtual environment lets you copy your current environment to a new environment before you install any new software or update any software. So that way you can revert to your earlier environment if the latest bleeding edge version of Pandas, or at least when I was preparing this talk, the latest bleeding edge version of Ipython wasn't able to start an Ipython notebook. There was just one little bug. And you can revert to your previous environment without having to go through a lot of work, and even just delete the one that was broken. Another useful command, set virtualenv project, lets you set the directory to be used in the particular virtualenv. So that means then when you activate that virtual environment, it automatically changes to the right directory for that project. And I find that really just a useful extra time-saving thing as well. The next part of my research toolchain I'd like to introduce is Ipython Notebook. I was wondering how many of you have seen Ipython Notebook? And how many of you are using it? Right, so quite a few have seen it, but not a lot are using it yet. Okay, so next I'll start up Ipython Notebook and have a look at the parts of it that I find useful for research. Ipython Notebook is started at the command line. I hope that's visible up there. First I activate the project's virtual environment using the work on command, and that also navigates to the project directory, as I said before. The next command shows how I start Ipython. The pylab parameter tells it to load pylab support, and inline makes it show the matplotlib graphs on the web page. Here's what the Ipython Notebook server startup looks like in the terminal window. I've zoomed in a little bit just so you can see the detail on the projector. Once it's started, it opens the notebook index page in your default browser. So I just wanted to show that so you sort of realise that it's not all happening in the browser. There is this back-end part that you're running that's then starting up the front-end part. Oops, wrong button. The first page it loads is an index of the notebooks in the current directory. We can create a new notebook, drag an existing notebook onto the window, or open one that is already in the directory. In this case, the shutdown button shows that the example notebook is open and has a connection to the back-end notebook server. This is what a notebook looks like. In this example, I'm typing in the main heading, so you can see that the current cell type is set to heading 1. A notebook consists of cells, and each cell can have a different content type. Available types at the moment are code, markdown, raw text, or various heading levels. The very new cell toolbar option on this page at the right is a new option that lets you make slide presentations in a notebook, and I think the person who developed it used it at SciPy last week to do one, but I wasn't brave enough to try to do that today. When I press Shift-Enter, the focus shifts to the next cell and the heading is displayed. This is the page layout I've used, with a heading giving the what the topic of the page is, and then a markdown cell with the name of the virtual environment that was used to develop that page. And I also use date headings on the page, because often with my research I'll have an idea, I'll sort of pursue it to a certain point, and then I'll put it aside while I work on some other things. So a page might even have different dates on it months apart, because I've come back to something later. Another thing about Ipython that I've found really great as a relative beginner to Python is its help facility. There's two types of help. A tooltip style tab activated help, where when you activate tab completion, it can bring up a tooltip of help about that function that you're using, and a pager area for more detailed help. When using the tab activated help, pressing tab a second time will bring up the more detailed help in the pager area. Here I'm showing another type of help activated by putting a question mark after the thing you want help with, and then running the cell. That loads in the pager area. I've also made the pager area, just in case you're worried that you don't get much coding room, I've actually made the pager area larger so that you could see the type of help it was providing. Using a second question mark and then running the cell will actually load the source code in the pager area instead of the help text for that function in the pager area. And that's been really great as a way of understanding what some of the underlying libraries I'm using are, how they're working, and getting more detail about how to run things than what perhaps the built-in help text gives you. The last thing about Ipython I want to mention is its magic functions, which provide utility features such as loading, saving, and running external code. These can either work on a single line or on a whole cell. And I'll quickly introduce the four that I've used the most. The first one I've found really useful is time it, for timing the execution of a cell. So that lets you profile whether you're improving the thing that you're trying to improve or not in a quick and easy way in the notebook. Pastebin for sharing code as a gist on GitHub when you're trying to get help from people in IRC, very useful. Save for saving a cell or cells to a Py file, and the matching load function, load magic for loading a file into a cell. And finally, the run magic to run a Python script. By default, this loads all the variables in the script into your interactive namespace, and I've found that very useful for loading the appearance settings for my matplotlib graphs to make them consistent across all my different versions and over time. Having had a quick intro to Ipython Notebook, here is an even quicker one to Pandas. Pandas provides data structures and tools for data analysis. The two main structures I've used are series, which is a single column of data, and data frame, which is a table of data. I'll be showing you the strong support for time-based indexing that Pandas provides. Are any of you using Pandas? Yep, so a few. So now let's move on to some examples from my research. So that's just a quick rundown of how the toolchain I'm using, but it's, I think, easier to see how it's useful by looking at a couple examples. For my science communication research, I've collected tweets using the Twitter streaming API with science-related keywords. In 2011, the keyword science collected about 13 million tweets. And I've since filtered out some spam and some non-English tweets, so now there's about 12 million tweets left in my dataset. Although tweets only have a short text, they also have a lot of metadata, so there's lots of different things you can choose to look at. And for this talk, I'm just using the number of tweets per day as the example. The first step is to get the tweets per day data into Pandas. Using tweets per day, and particularly for this demo, it gets the 12 million tweets down to a single record per day in 2011. So it's no longer really big data once you've done that. And so you just end up with the number of tweets for each day. So my collected science tweets are stored in a CouchDB database. So I run a query to load the tweets per day. Using the list returned from CouchDB, I create two new lists, a date list with Pandas date times and a data list with the number of tweets for each day. The date list is then converted into a date time index and the science tweets series is created. My data collection failed by running out of disk space on April Fool's Day, which is the 31st of May UTC, and because it was April Fool's Day, it couldn't send me an email because it couldn't create it because it didn't have disk space to tell me it had run out of disk space. So I didn't notice for a week or so, and then once it had been a week, I thought, well, I'm going to have to deal with that in my analysis, so I waited until the university could pay for a new hard drive instead of me buying one. So it got fixed on the 12th of April. So from the 31st of May and the 12th of April, I have both partial days of data, and the days in between don't have data and need to be excluded. By converting the tweets per day from integer to float, I can then use Pandas support for missing data to exclude the outage by setting them to NumPy, not a number. And that's really handy because otherwise you've got the zeros and you're not quite sure whether they're a zero because nobody mentioned science on that day or they're a zero because of missing data. Working in Ipython Notebook, another advantage is that it's really easy to check that things have worked properly and to interact sort of iteratively on things. Here I check that my start and end date are what I expected and that the masking of the missing data has worked. The ability to quickly plot a Pandas data frame or series is one of the features I find really useful. To just be able to say data frame or series.plot and see that the masked data isn't appearing on the graph is a really quick way of confirming that it's worked. In the previous example, I used science tweets first 1D to see the first item in the series. There are many ways to access the first or last items in a series or data frame, and some are shown here, including using a date string to access a particular day. The last example is looking at the first week in 2011. So Pandas has all these powerful sort of date time options of ways of looking at it, and I just wanted to give you a quick glimpse of those. Notice that there are only 2 days in the first week of 2011, so it's not a mistake that there's only 2 things. I actually went and checked a calendar. There is only, from the Pandas week is from Monday to Sunday, so Monday and Tuesday were the first week of 2011. I keep all my Pandas dates as UTC, so I have fewer time zone problems, but I've still been caught out by the way so much software defaults to expecting month first date strings. And so I tend to use the longer pandas.datetime function to specify dates to make sure I get the date I expect. Because that function expects you to give it a year and then comma, like it's not a string format. You're actually passing it the date you want to make sure you get what you get. Pandas has added a day first parameter date parsing function, so that might be another way of telling it what you're actually doing with your dates. I can zoom in on the earlier graph by using a date range or a date index. Or a date range or an index range. Doing this lets us see what seems to be a weekly pattern in the number of tweets containing the word science. The semicolon after plot is there so that it suppresses the output of plot to the notebook, so we just get the graph. We don't get any matplotlib sort of conversational stuff that it might tell us on the way. So is the pattern weekly? And if it is, which days are the peaks and troughs? We can't tell that from that graph yet, quite. Let's zoom in further and add labels on Tuesdays and Saturdays. I didn't just use the matplotlib dates function to format the date tick labels, because matplotlib doesn't understand pandas date time objects, and gives very strange results if you try to pass pandas date time objects to it. The code shows you how to fix the problem by passing the pandas data to matplotlib instead of using the quick pandas.plot option. On line 3, the toPyDateTime function converts the pandas date times back to Python date times. So now on this graph we can see that the peaks are in the middle of the week and the dips are on weekends, showing that people use the word science on Twitter more in the middle of the week than on weekends. And this actually matches a broader pattern of Twitter use that other people have reported, where people generally use Twitter more at work or at school than at home. Another thing that Pandas makes much easier is resampling for different time periods. So here I decide that my daily frequency, I'd rather be looking at monthly frequency instead of, sorry, I was looking whether I did it weekly or monthly. Monthly frequency. And so I resample by monthly frequency, saying that the way I'd like to do that is by the mean number of tweets in that month. And I can choose lots of different ways of doing that in that function. I've plotted then the monthly tweets in black, so you can see that smooths out all the variation, and the daily tweets in blue on the same graph. Pandas also provides a range of analysis options for both series and data frames. The describe function gives the summary of the statistics as shown and just gives you a bit of a glimpse of the sorts of things available. It's also easy to use Pandas with other tools like stats models for more advanced analysis. A data frame can be made by combining series. A feature of Pandas is it automatically aligns the data even if the series are of different lengths. When working with time series data with other software, this is often really hard to do. In this case, combining the daily tweets with the resampled monthly tweets results in most of the tweets per month values being set to missing, and that's what the not a number are in the table. It also shows the nice default output for a data frame. If we don't print it, if we just have it as the last object in our window in Ipython, it displays it in this nice way. If it makes sense for your data, you can also fill the not a number values in various ways. Adding columns to a data frame is also very easy. The first line creates the cumulative sum using Pandas built-in cumsum function. Built-in cumulative sum function. The second uses the tweets per day column to calculate the daily percentage of the year's tweets. The third line uses the data frame index and then gets the days of the week. And then the group by function lets you group the data frame in different ways. So if we wanted to see the number of tweets received on each day of the week, we could do that like in this group by. But you do have to think about what your columns represent, because in this case, the tweets per month and the cumulative columns have both become rubbish when we've done them as by day of week. They just don't make sense anymore. So it's easy to exclude them by using Pandas' column selection method of double square brackets. So we just drop them out of what we're working on from then on. As I said earlier, Ipython Notebook makes checking the numbers make sense easy. Here I check that the percentages add to 100 and the sum of tweets per week day is the same as the tweets per day, so that I haven't, the group by hasn't done something unexpected. And the last feature of Pandas I'd like to show you is how easy it is to export a data frame to LaTeX. In the toLaTeX method, I've specified the columns I want included, and there's lots of other parameters you can use to customize the LaTeX output. And if you've worked with other software and you're working in LaTeX, you may have had to do some of the painful cutting and pasting that this now avoids to get tables into your LaTeX document. So, any questions?
If anybody's got any questions, as usual, come down to the microphones down the front.
Thanks. I'll just hold it. You mentioned, if I understand correctly, that when you start up Ipython, there's some environment that's kind of configured into it so that it's like a known environment for your plotting?
Yes.
How complex is that to set up?
It's built in. You just put those two lines onto the command line and it will automatically load. So I'm not 100% clear on what the PyLab includes, but I know it includes, it means it's already included NumPy and all the things I end up using. I don't have to include them in I don't have to import them because they're already there. To be used.
Sorry, I'm a bit of an Ipython noob, so...
Yeah, that's fine. No, it's just that... So I know that so then I could, in my code, I could do np dot without having done import NumPy as np. So it's giving me quite a few of those sciencey libraries there just by default.
Okay, thanks.
And the PyLab inline is just stopping the matplotlib graphs from popping up into a different window.
Hi, thanks for a really clear talk, showing all the steps of what you're going through. I was wondering if you, what's the future you see in terms of maybe sharing or publishing your notebooks actually as part of your research, or is it just simply for your own benefit that you are using them in this way?
Yeah, that's a great question. I think that's one of the things I'm really excited about this. I have got one of my notebooks open, the one that I've just been working on. I'll put that up. So the notebook as it's used during the research probably wouldn't be published. So this one has, first of all, I just tried to do a Fourier transform. I'll just whiz down, not looking at any of the code. Then, oh, sorry, it hasn't gone up there. Sorry. Oh, won't do that. Basically, there's now a notebook, NB Viewer is available to let you publish notebooks as read-only, but then people can also download the notebook and it becomes runnable again when they've downloaded it. So yes, I think Ipython Notebook is going to be a really valuable tool for open science because it lets you, already lots of people are publishing their notebooks through this NB Viewer option, and it will be, I think it will be a way that you'll be, because you can include LaTeX and all sorts of other stuff, math stuff into your Ipython Notebook, you'll be able to actually write your whole paper in Ipython Notebook and publish it with the data and the code in it, which will be really an interesting step forward.
I guess my question was, are you actually intending to do that with your research?
I'm hoping to do that. It will be a bit of extra work because of having to, I wouldn't want to publish all my intermediate steps, but I do think it's worth, I do tend to, for each chapter that I'm writing, condense all the things that create the final tables and graphs into a couple files. And my intention is when I finish the PhD to go back through those and maybe clean them up a little bit more and then publish all of those so that people can repeat what I've done. The problem with Twitter data is I'm not allowed to publish the Twitter data. Twitter's put really big restrictions on researchers. So what I'd have to also do, I can publish the Python code and all the record IDs for you to re-extract all the data. But for 12 million records, you might have to wait a little while.
This might not be a Python question, and if we don't have time, it might not be worth discussing, but in your original Twitter data set, how did you handle the term science for science versus science fiction, say, or other uses of the word? And were you looking at that, and did you use Python to filter that set at all, or anything like that?
The filtering I've done has been using Python, and because that's been part of the analysis. So the original collection just collects every tweet with the word science. And so it does turn out that I've got, well, part of my foreign language filtering was because I have a problem with my data that science fiction is actually a used word in lots of foreign languages. So you do pick up a lot of foreign language tweets using science. But that filtering was done in Python, yes, for that. Does that answer?
Oh yeah, yeah, thank you. I was curious.
This is probably our last question.
Thanks for a great talk. I hadn't actually seen some of those virtual environment stuff, and it's very exciting. My question is, brain blank.
Yep.
Oh yeah, revision control. So I'm a software engineer. I work in industry. I'm just wondering, how much do you use revision and control, and is it possible to use it with Ipython Notebook? And
yeah, Ipython Notebook is, I'm going to get this wrong, but I think it's a JSON format. So because it can have images in it, they'll also be saved in the JSON file, so they can get a bit bulky and not ideal for version control, like because you've got text mixed in with data. But it works, and I do use version control. I'm a big fan of Git. And I've noticed in the latest version of Ipython Notebook that they now have checkpointing. So I think they're moving towards integrating with version control within the notebook. So they have autosave, is just the one that came out last week now has autosave, and then when you save it says checkpoint set. So they're doing some sort of version control-y thing now too.
Cool. Thanks a lot, Brenda, for your troubles. There is some Norwegian blue and a mug. Please, everyone, thank Brenda.